Next we will see the second chapter, that is trigonometry. So first we will see how the trigonometric ratios and the fundamental trigonometric identities. So we have learnt in earlier classes what are the trigonometric ratios are: sin theta, cos theta, tan theta, okay, and cosecant theta, secant theta, cot theta. These are basically inverse of your sine. Okay. How did we define these trigonometric ratios? We have a right angle triangle. So let this angle be theta. Then I will call this is a hypotenuse. This is the opposite side, opposite angle theta, and this is the adjacent side. And then we have sine theta equal to opposite side by hypotenuse, cos theta equal to adjacent side by hypotenuse, and tan theta equal to opposite side by adjacent side. Correct? So, and the inverse of the functions, inverse of these trigonometric ratios are cosecant theta, that is equal to 1 by sine theta, that is hypotenuse by opposite side, and secant theta equal to 1 by cos theta, that is equal to hypotenuse by adjacent side. Cot theta is equal to 1 by tan theta, that is equal to adjacent side by opposite. So this is the way we learned the trigonometric ratios in our earlier classes. Okay. So now we saw in our earlier lectures, we saw this theta can have both the signs. With directed angles can have positive theta as well as negative theta depending upon the direction of the angle we are taking. Okay. So it is better, convenient to define these trigonometric ratios in a coordinate system, because we are defining the directed angle in terms of a coordinate system. Okay. So what we are going to do is we are going to have an coordinate system. So, and this is x, minus x, y, and minus y. So I am going to have a one point. Okay, we'll say this point B, P, which is x comma y. Okay, so and let me join this distance. Okay, so this is the point, and let me call this distance as r. Okay, so what will be this distance?
Y.
This is your y. Okay, so this will be your y, and this one will be your x. Correct? This is x, x, y. Okay. So now we define the angle like this, positive angle, theta. Okay. So let me remove this here. Okay. So now, so what will be your sine theta? Sine theta will be opposite side by hypotenuse, that is y by r. Okay. Cos theta?
X by R.
Cos theta is x by r. And tan theta?
Y by
Y by
X.
x. Okay. Similarly, your cosec theta will be r by y. Sec theta will be r by x. And cot theta will be x by y. Okay, so and yes, so this is a way. So now, if I have another point at the same length r, so let me use another color. If I rotate this by a different angle, okay. Now this point is here, so this is going to have new xy, right? So let me call it as q. This is going to have x1 comma y1, and this radius is same r because I am rotating it. Okay. So will this ratios change formula? It won't, right? Because now this is what? This is your x1 and this is your y1. Okay? So then suppose if I call this angle as theta 1, again we have sine theta 1 will be equal to your y1 by r is same, okay, and cos theta 1 equal to x by x1 by r, and similarly tan theta equal to y1 by x1, and we can have. So basically, as I keep rotating, all what happen if I take a radius, this length is r, and if I keep rotating for all the new angles, okay, so for the new angle, the trigonometric ratios is nothing just divided by the coordinate points, correct? So that means I can, in fact, so I can always draw a circle so what we can do, so that means I can draw a circle of radius, how much? R, okay, and this point is P of x comma y, okay, and then for all this angle theta, so all I have to do is, so if I take for any this circle at any point on the circle, every point is going to have an xy, so different xy. So then your sin theta equal to what? Sin theta is y by r cos theta equal to x by r, and tan theta equal to y by x. So this gives you so all you have to do is give a point at the distance. Okay, so this one we can find out all the trigonometric ratios from here. The why this is interesting is I can always take from theta equal to 0 to 90. I can keep doing for up to 360 degree. Okay, so and now if you see, so one interesting thing is, so if we, what will be the coterminal angle? Coterminal angles. Suppose if this angle is theta, correct? So the coterminal angle means, again, this is going to make a full round and come back here. Am I right? So all, will the trigonometry ratios changes for coterminal angles? Will it be changed? No, right? Because the ray is same. So the trigonometric ratios of coterminal angles are equal. Okay? And now, so now if you see, I can always have a question. So we find, we know earlier trigonometric ratios is a function only of this angle theta. Okay? But here it's saying it's a function of y by r. So it's going to depend upon your xy axis as well as distance r. Okay? But it's not just going to be, so trigonometry ratio is depending upon your xy and r also. So if I change the r, will the trigonometric ratios will be different? Why? Why it won't be different? So let us try to see. So what am I going to do is, so this is your P of x comma y. I am going to draw another circle along this. Okay? So then this is the same angle. I am going to find out the trigonometry ratio of theta using this circle. So what am I going to do? I am going to extend it here. So let me call it as q, and this will be a new x and y. Okay, it's not same x, so it will be x1 comma y1, and this distance will not be r, so I will call this distance as r1. Okay, so now if I drop a perpendicular from here, okay, are these two are similar triangles? So what I am saying is, so this is O, A, B. So triangle OAP is similar to triangle what? OBQ. Is that right? Why? Because all 90 degree. This angle is same. So obviously this angle also will be equal. So these two triangles are similar. So we know for a similar triangle, the ratios of the sides are all equal. That means what happens? So this is y1 by y1 by y will be equal to x1 by x equal to r1 by r. Correct? So therefore, if I take this one here, what you are going to have, let me take these two equations. y1 by y equal to r1 by r. Therefore, y1 by r1 equal to y by r. Correct? So this is also equal to y1 by r1. Correct? So similarly, let me take these two. So what happens? So x1, I take this one here, x1 by r1 equal to x by r. Therefore, this is equal to x1 by r1. So similarly, I can always take these two and find this will be y1 by r1. Correct? So, whatever the angle, whatever the radius you take, these ratios are going to be constant. Okay, therefore, this is not going to depend upon the radius. Okay, so it is, when I say this is not going to depend upon it, so it is easiest way, I am not going to use an arbitrary circle of radius r. What I will use a unit circle. Okay, so when I use a unit circle, what advantage of unit circle? My r is going to become 1. Am I right? Unit, this is O, so my r, this is going to become 1. Then I will take only this p of x comma y. So in that case, then my then the trigonometric ratios can be written as sine theta equal to y, cos theta equal to x, and tan theta equal to y by x. Okay? So because radius is 1. And now it's also easier to find out your trigonometric identities, fundamental trigonometric identities. Okay, so if I draw it like this, so this is your x and this is your y. So from the Pythagoras theorem, we have x square plus y square equal to 1. Okay, and let me take it from here. So from here, so x square plus y square equal to 1. Therefore, x square is nothing but y square equal to cos theta equal to x square is equal to cos square theta, y square equal to sin square theta. So therefore, sin square theta plus cos square theta equal to 1. You got it? Because x is equal to cos, y equal to 1. And similarly, you can find out more also. So then I can have this one. What is the other one? Inverse of it. Cosec theta equal to 1 by y. Sec theta equal to 1 by x. Cot theta equal to x by y. So let us try to take this one. So let us take these two. Let me combine because the denominators are x. I am going to combine them both. Okay, so I am going to have sec square theta plus sec square theta will be equal to 1 by x square and tan square theta equal to y square by x square. Okay, so if I take a difference of it, what happens? X square is the denominator is common. 1 minus y square. 1 minus y square is nothing but x square. So become 1. So I will take a difference. Sec square theta minus tan square theta that is equal to 1 by x square minus y square by x square. That is equal to take the x square commonly here. So 1 minus y square. So 1 minus y square is nothing but x square. So this is going to become x square. So it cancels and going to become 1. So this is your second trigonometric identity. First one is sine square theta plus cos square theta equal to 1, and then sec square theta minus tan square theta equal to 1, and the final one is we can combine what those two? These two. See, both of them have a denominator of y. Okay, so let me use that. So cosec square theta equal to 1 by y square and cot square theta equal to x square by y square. So if I again take a difference of it, 1 by y square minus x square by y square comes common, so 1 minus x square is nothing but y square, it becomes 1. So therefore, cosec square theta minus cot square theta 1 by y square minus this one. So this is going to y square. I'll keep it common. So this is 1 minus x square. So 1 minus x square is nothing but y square. So y square gets cancelled, and we will get here as 1. So these are the three fundamental trigonometric identities. Cosec square theta minus cot square theta equal to 1. So these are the three important fundamental trigonometric identities we will see. Okay.